Hi, Mr. Kane here. I'm going to be talking to you today about how to make precision measurement techniques, or in other words, how to select and measure with the proper glassware in chemistry lab. When you take a look in chemistry lab, you'll notice that we've got a bunch of different types of glassware to choose from. We've got graduated cylinders, we have beakers, we have Erlenmeyer flasks, and we also have volumetric flasks. And it's important that you know how to pick out the right measurement device for the right job. So we're going to talk about that today. All right. First off, when you look at them, they can get a little confusing because the scales can be different from each other. If you take a look over here at this particular one, this graduated cylinder starts with 7, goes up to 8 here. So we got 7, we got 8. Let's see, we've got lines in between. We've got 1, 2, 3, 4 lines in between. So this particular one has a scale that goes by 0.2 milliliter values. So this would be 7.2, 7.4, 7.6, 7.8, and then finally we get up to this line, which is 8.0. This graduated cylinder is a little bit different. This is 15 here, this is 20 over here. There's several lines. There's big ones and small ones. 1, 2, 3, 4, 5, 6, 7, 8, 9 total. Alright, so I'm going to try this out. This is probably 16, 17, 18, and 19. So the big lines represent one place value of movement, and the smaller lines represent a half a place value of movement. So these have changes of 0.5 milliliters. Over here on this graduated cylinder, we go from 70 being here and 80 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hey, this is easy. This is graduated in 1 milliliter increments. So this would be 71, 72, I'm going to skip 75, 76, 77, 78, 79, and finally there's 80. Okay, this graduated cylinder is a little different. Here's the 300 mark, here's the 400 mark. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 lines in between. So that probably represents tens of milliliters. That's the graduation on this one. So this would be 310, 320. The big one here would be 350, 360, 370, 380, and 390. We want to read with what's called precision. If you look at the way that liquid fills inside of these graduated cylinder, you'll notice that it takes on this curved shape like that. And this is what's called a meniscus. Okay, that's the meniscus right there, is that curved shape that happened. The proper way to read the graduated cylinder is to read from the bottom of the meniscus. So in this case, 15, 16, 17, 18, 19, that's 19 and a half, that's 20. It got most of the way past halfway, so I'm going to say this is like, since this is 19.5, a little bit more than halfway would be 19.8. So I'm going to read this as 19.8 milliliters, since it got a little bit past halfway, past 19 and a half to 20. Another important thing to note is right up here. This device has been graduated so that it is correct at 20 degrees Celsius. So the liquid inside of it needs to be exactly 20 degrees Celsius, otherwise the reading is going to be off by a slight amount. So sometimes that can cause a little bit of trouble in labs. Sometimes we get a little bit of error because the liquid that we're measuring isn't exactly 20 degrees Celsius. It's really difficult to read a meniscus when you're above it. If you're at an angle, a normal angle from the tabletop, you can see here that it's really difficult to tell where the meniscus actually is. Is this the meniscus down here? Is this it here? Is it in between? So when you actually read a graduated cylinder or a beaker, any glassware as a matter of fact, what you need to do is you need to get your eye to the level of the meniscus in order to read it properly. Now this is what's known as a volumetric flask. The volumetric flask is the most precise of all of our measuring devices, all of our glassware that we have. You can see here that it contains exactly 500 milliliters at 20 degrees Celsius, if you fill it right. If you fill it right, the bottom of the meniscus should be right at this etched line that's right there on this volumetric flask. If it's below the line, well, then you don't have exactly 500, you get a little bit less. If it's above the line, you've got a little bit more. Here's some practice. See if you can figure out what the precise reading should be for this graduated cylinder. All right. I'm going to walk you through it. Here's 8, here's 9. These look like they're 0.2 milliliter increments. So that's 8.2, 8.4, 8.6, 8.8. So if this is 8.8 and this is 8.6 down here, looks like it's a little bit closer to 8.6 than it is to 8.8. So I'm probably going to say it's 8.65 milliliters. Okay. Notice I don't think it's exactly in between. If I thought it was exactly in between, if I thought the meniscus was right here, I would have said 8.70 milliliters. All right. One of the keys here is this. Since this measures to the 10th place, I want to make my measurement out to the 100th place. We'll explain why that is later, but that's important for right now. All right, practice reading on this one. It appears that the smallest scale on this is 15 to 16 to 17, 18, 19. So it appears that the smallest is readings at 0.5 milliliters. That means that since this is the 10th place, I'm going to want to read my reading out to the 100th place. Looks like the bottom of the meniscus looks like it's just above this 18. So I'm going to want to read it at 18 milliliters. Now remember, I want this out to the 100th place, so I think it's almost exactly 18. It's just barely above that, so I'm going to say 18.0, maybe just a little bit above, 18.05 milliliters. Now it's okay if you don't have the exact same number here. That last digit is what we call a guess digit. So you can have that be plus or minus probably about 3 units. But these first three should be exactly the same as mine. Also, you should be using units. Press pause and see if you can come up with a good estimate on this. So these look like these are ones. This is 75 here, so these are ones of milliliters. Since this is the ones place, I want to guess one digit beyond the ones place. I'm going to guess to the 10th place when I make my measurement. So that's 75, 76, 77, 78, there's 79. So this is 78, this is 79. It's not quite halfway. I'm going to say that it's about 79. Now there's the ones place right there. I want to guess one digit past it. So I'm going to say, like I said, it's not halfway, so I'm going to say 79.3 milliliters. And that's what my guess is going to be. Press pause and see what you get for the reading on the beaker here. The distance between these two marks is tens of milliliters. That means that my place value is in the tens place. That means I'm only going to be able to guess to the ones place when I do my measurement here. So let's see, it goes between 10 and 20. I think halfway between 10 and 20 looks like it's right about there. The meniscus is just down here. That looks like it's probably going to be a 4. So I'm going to guess that this is 14 milliliters. See what you get. Now, you may have noticed that the tricky part about this is that this is full of water, but which scale do you read? If you look over here, 400, 300, 200, does it make sense to read backwards? It doesn't. So if I had 100 milliliters, here's a little bit more water, 200, a little bit more is 300. Well, it's somewhere between. This is in 50 milliliter increments. Again, 10 milliliters is where my place value is for each of these increments. So I'm going to guess one place value farther than tens. I'm going to guess to the ones. So when I say 200, it's 250 here. The meniscus is right here. Halfway would be 275, right? So that's halfway. Maybe 260-ish, or some people might say 270-ish. So somewhere between 260 and 270 is probably right. I'd say even 260 to 265 would probably be the best guesses. And don't forget your units of milliliters. Okay. Finally, reading this. This is an Erlenmeyer flask. Notice it's a little bit different reading an Erlenmeyer flask. The distance here is a measure of 25 milliliters. And the distance here is a distance of 25 milliliters. Notice those two distances are not the same. This probably isn't a very good tool if I want an exact measurement, for both the reason that the increments are in 25 milliliter increments, and also because I really can't tell very well what the distance is going to be for a precision measurement here. So if I wanted to get exactly 80 milliliters, this would not be the device I'm trying to get. I'm probably going to guess that 50's here, 75's here. I'm going to guess that this is somewhere around 70 milliliters. You might have guessed 68 milliliters or 70, maybe 71 milliliters. So somewhere in that range is probably about right. Notice one's place value. I probably should have one more digit here, so 70.0 or 68.9, 71.0, something like that. All right, self-reading on glassware. See if you can complete this. We're going to check it in class tomorrow. It's your own little quiz. Press pause as you need to. All right, make sure to bring this quiz back with you, your answers to those 6 questions, back to class with you tomorrow.